Hey there, kiddos. In this lesson 5.5, we're going to go over the distributive property, a property that we've talked about a little bit before, but now we're going to look at it explicitly when it comes to expressions. So, distributive property. Our objective is that we want to be able to apply the distributive property, to apply it so that we can generate equivalent expressions, meaning that whatever we started off with is going to be equal to whatever we end up with. So, key things to remember. The words to multiply a sum or difference by a number, multiplying each term in the sum or difference by the number outside the parentheses. That's what the distributive property is. So when we look at these examples here, 3 parentheses 7 plus 2 means that we're multiplying the 3 times both the 7 and the 2. So 3 times 7 plus 3 times 2. If it's subtraction, the same applies. 3 times 7 and then 3 and then minus 3 times 2. Right? So keeping that in mind, let's take a look. Using the distributive property to simplify each expression. Well, for letter A, we're multiplying 4 times n and then 4 times 5. Well, 4 times n is 4n. 4 plus 4 times 5 is 20. What about letter B? Letter B, we're multiplying 12 because that's the coefficient outside of the distributive, right, outside of the parentheses, excuse me. And we're going to multiply that times 2y, which would give us 24y, and then 12 times 3 is 36, but remember it's subtraction, so it's minus 36. So 24y minus 36. 1/2. What is 1/2 of 6? Half of 6 is 3, and half of 2 is 1. So this is going to be, when we simplify it, 3y minus 1z, or just z. Remembering that when we see that variable by itself, it's understood that the coefficient 1 is in front of it. Now, when we look at D, what's different about D? We see with D that there are 3 terms in the parentheses. Does that change the distributive property? It most certainly does not. We're still going to multiply that 9 to each of the terms inside the parentheses. So 9 times 6, 9 times x, and 9 times 2. So we're going to get 54, 18, and 9x. However, are there any terms that we could add together to simplify? The answer is yeah, commutative property. When we look at 54 and 18, those are both constants. And because they're both constants, we can add them together. 54 plus 18 will give us 72. So we have 9x plus 72. So far, so good? Let me pause for a second and give you a chance to copy down any notes. You can also pause the video if you need to in order to copy anything down if you feel as if that Mr. Pierre is going a little too fast. Let's take a look at example number 2. Example number 2, we're now going to combine like terms. Like terms are terms that have the same variable or same exponent. We saw before, constants, we can clearly see what the constants were. 3 plus 7. Those are constants. That's equal to 10. 3 minus 7, or 7 minus 3. We see those are same as well. Those are constants, so 7 minus 3 will give us 4. Now, when we're looking at like terms, they have the same variable, or they're just constants, all right? And they're also raised to the same exponent. So when we're looking at A, well, we're going to use commutative property to change the order, get the like terms that are together. So 3x and 2x, and then 9 and 5. Now, when we're looking at the distributive property, when we're looking at 3x and 2x, well, x is the same, so we're going to pull that out. So now we have 3 plus 2, parentheses, x plus 9 minus 5. And when we simplify that, that's equal to 5 and 4, so we have 5x plus 4. What about letter B? Y plus y plus y. Remember, the coefficient 1 is in front of that, so there's 1 plus 1 plus 1 will give us 3y. What about letter C? Letter C, we see that we have to distribute, meaning we have to multiply before we can add. So let's multiply first. When we're going to use the distributive property, it's 2 times z, and then 2 times 5y. 2 times z is equal to 2z. 2 times 5y would give us 10y. Well, the z's, we can add them together. So 7z plus 2z gives us 9z. So that our final answer, when we simplify this, would be 9z minus 10y. Here's a real life example. Jose is X years old, and his brother Felipe is 2 years older than Jose. Their aunt, Maria, is 3 times as old as Felipe. We want to write and simplify an expression that represents Maria's age in years. Well, what do we know? Well, we know that when it comes to Jose, we're told that Jose is X years old. So that just means X. What else do we know? We know that Felipe, his brother, is 2 years older than Felipe. How do we write that? Well, that would be X plus 2. And what about Maria? We know that Maria is 3 times as old as Felipe. So how will we write that? Well, that's going to be 3 times the X plus 2 that was Felipe. Now we want to simplify the expression that represents Maria's age. All right, so 3 times X will give us 3X, and 3 times 2 will give us 6. So Maria's age is going to be represented as 3X plus 6. Do we know the exact age of Maria? No, we don't. But we do know, once we know what Jose's age is, we can then figure out what Felipe's age is, and then we can figure out what Aunt Maria's age is. So if Jose were 10 years old, we could substitute into this expression. If Jose is 10, that means X is equal to 10. So X times 3 would be equal to 30. And then 30 plus 6 would be equal to 36. Felipe, who is 2 years older than Jose, Felipe would be equal to 12. And then Jose, we know, is equal to 10 because that's what we're given. Alrighty? So for today, our lesson of distributive property, of making sure that we understand how to write the expression, how to then create an equivalent expression, is what we're going to work on in class today. Excellent. Let's get to it.